Hello everyone, my name is Moon. My project is to automate the distributed training for deep learning. I'm consulting with a company called Paperspace. Paperspace provides cloud GPU service. One problem they have is to manually set up the distributed training for their clients. Therefore, they want to reduce the setup time for distributed training, and they are especially interested in a complex natural language processing model called GPT-2. The reason distributed training is so popular is because it empowers you to have quicker iterations in exploring new models. And it also allows the model to learn faster from new information and provide more value for your business. But how people implement distributed training. The learning curve is steep. You need to understand what is your running environment and what is your infrastructure. You also need to figure out what parallel strategy you want to use. The problem is most data scientists are not familiar with those concepts. It takes them days and weeks to just get started. The whole process not only daunting, but also slow down their progress. So that's not very nice. Data scientists are very expensive, and business is paying for that. That's why we want to automate this. Another question is why GPT-2? GPT-2 is a natural language processing model. It has, same as other language models, it has many business use cases. But what made GPT-2 stand out is that it performs very well for tasks and datasets it has never seen before. This is great news for business because this means you can save all the time and money in gathering and cleaning the data. And this also means your fine-tuning process will be much faster. But GPT-2 does have one problem. It is huge. It can have billions of parameters. That's simply too big to fit into a single GPU. And that's why Paperspace want to start from GPT-2. This is a demo of the final product we want to deliver. At the end of the day, we want our users have a simple, clean web UI where they can just click and choose what tasks and datasets they want to use, and what framework and model they want to play with. But once they choose the type of the GPU and the number of the GPU, they can get an estimated training and the estimated total cost, so that they can make a more informed decision on running their experiments. Once they confirmed the whole setup, the code for distributed training will be generated for them in the Jupyter Notebook. Inside the Jupyter Notebook, this is the part where the user input are passed from web UI are passed in to generate the code. So if the user want to change those values later on, they always have the access. And behind the scene, this is the most important part, how I actually implemented the distributed training. To serve as many users as possible, I developed both PyTorch-based solution and a TensorFlow-based solution. For PyTorch, I used the built-in method called distributed data parallel. For TensorFlow, I used a library called Horovard developed by Uber. This is the most important part of the code, but if you zoom out, this is a whole pipeline for my project. For both solutions, I have containerized with Docker so that I can run and scale it easily on many instances. For parallel strategies, data parallel is quite straightforward. It's not dependent on the model. The entire model is replicated and loaded to each GPU. But model parallel is much more complicated and challenging. You cannot just call a method and plug in. You have to figure out which part of the model can be parallelized and which part of the model have to be synchronized. This is the last slide of my presentation. My final application can run both on single node of multi-GPU as well as multi-nodes of multi-GPU. As for the future work, there are many tasks can be done. On the right side are the tools I have learned and I want to learn more in the future. As for myself, my background is in biology and statistics, and I really enjoy solving problems with friends or as a team, and deliver whatever I build to the end user. That's the end of my presentation. I'm happy to take any questions.